So in this first section, I'm going to explain the general context of the Johnson & Johnson project and why the LoadMax tool was created. Johnson & Johnson is one of the largest healthcare companies in the world and handles millions of units of medical products from sutures and surgical instruments to orthopedic devices. To meet international demand, a key part of its logistics relies on the distribution center in Memphis, which ships large volumes to countries such as Belgium, Singapore, Japan, and China. Now, the main challenge was the construction and loading of the containers, meaning assembling the Gaylords, arranging boxes and organizing them inside the 53-foot trailers. Used to be done manually with spreadsheets, row calculations, and the operator's experience. This created several problems: poorly used space, more trunks than necessary, higher transportation costs, and increased CO2 emissions. Additionally, although the ideal scenario for cost efficiency will be to wait for more products and completely fill the containers, this is not feasible. Is healthcare. Also, Johnson & Johnson is obligated to deliver quickly without delaying orders or accumulating inventory. This is why the challenge was to find the optimal point, consolidate each shipment as much as possible without delaying it. This is where LoadMax comes in, a web tool developed by Advanced Analytics and Data Science team. So LoadMax generates three-dimensional plans for loading boxes into Gaylords and then loading those Gaylords into the trucks. What's important is that it does this automatically and optimally using mathematical models, integral programming, and advanced heuristics. Instead of relying on intuition, the tool now produces precise, reproducible, and consistent loading plans. In summary, the introductory part of the project shows how Johnson & Johnson decided to transform a manual and costly process into one based on advanced analytics in order to improve service, reduce cost, and increase efficiency across the entire logistic chain.
Okay, in the second part, I will explain the technical basis of the project and how LoadMax works internally. The problem of loading containers and pallets has been studied for decades. There are algorithms in two and three dimensions, many of them based on intricate programming, heuristics, research, or hybrid techniques. The problem is that these methods are often computationally very complex and can take too long if applied directly to daily operations, like those of Johnson& Johnson. That's why we will use an approach called math heuristics, which combines exact models with intelligent rules. These combinations allows us to obtain very good solution in just a few seconds. The general operation of LoadMax is divided into four steps. Step 1. Estimating how many gaylords and trucks we will be needed. Based on the volume, weight, and type of product, the system calculates how many gaylords should be built and whether they will be full, three quarters, half, or quarter full. This also considers special rules, for example, a product that cannot be mixed or that require a specific package. Step 2. Assigning peaks to each gaylord. The peaks are or boxes are grouped by attributes such as customer and destination. Then they are sorted from largest to smallest volume to optimize space utilization. They are assigned to the gaylord respecting weight and volume limits and avoiding impossible combinations. If they are very large, the system automatically divides them so they can be accommodated. Step 3. Three-dimensional validation using the optimized algorithm. This is where the more mathematical part comes in. The tool generates two-dimensional layers within the Gaylord, solving a model that places boxes without overlapping. If then add boxes to empty space, if they are not increase the total height, if their configuration is variable, the recommended Gaylord shape is adjusted. The fourth, stacking inside the truck. LoadMax solves our second mathematical model to decide how to stack the Gaylords inside the truck, minimizing occupied positions while respecting height, weight, and spatial category restrictions. These style problems occur several times a day, generating clear and ready instructions for warehouse personnel to follow this precisely. Short load max transforms an extremely complex problem in a practical and quick decisions for daily operations.
In this final part, I am going to explain how load mass was implemented at Johnson & Johnson, the result with our chip, and the future direction of the project. Since message distribution centers are operated by a third-party logistics provider, implementing the system requires coordination across multiple teams and organizations. Because of that, deployment happened in four major stages. Number one is education and training. It was essentially that the workforce personnel understood the value of the new tool. Loadmaps were replacing a method based on human experience with one driven by optimization models. So the team conducted on visits, training sessions, and feedback meetings. This helped align expectations and refine the tool. Number two, test and learn period. Before the tool went live, the team run real operation tests. These tests reveal case adjustment, how often data should be refreshed, issues with product dimensions, and the best way to generate clear, practical instructions for the floor operators. Number 3. Deployment and hypercare. After validation, LoadMass was officially deployed of the first international shipping lane. During this phase, performance metrics such as mean absolute percentage error were monitored weekly. Any issue report by the operation were addressed immediately to ensure reliability. And number 4 is steady state operation. Once the tool is established, the focus shifted to maintain accuracy and printing performance decay. New metrics such as chargeability, weight optimization, and CO2 reduction were added to measure load their impact. Now, what result did load mass deliver? The impact was substantial, is a 12% increase in container utilization, nearly 20% reduction in CO2 emission in sublines, millions of dollars in save across 2022 to 2024, a reduction of thousands of failures per year, and less congestion, fewer stops required, and faster outbound operation. Because of this result, Johnson & Johnson plans to expand LoadMass to additional distribution centers in Europe and the United States. On top of that, the analytics team is exploring new algorithms in Provence, including parallelized meta-theories, quantum computing projects, and reinforcement learning to support layers, markets, and higher shipment volumes. In conclusion, Dotman doesn't just optimize container loading, it transforms the international logistics process for Johnson & Johnson. It reduces costs, expense of delivery, minimizes environmental impact, and reinforces the company commitment to serving pan efficiently and responsibly.